Okay, so we're going to be talking about lines in the quadratic formula, quadraticness. So line slopes, parallel and perpendicular lines. I'm going to spend some time on this, and quadratic formula. So here's an interesting kind of sort of fact. Let's say suppose we consider two lines where we have line 1 is equal to m1 times x plus b1. And this m1 is again the slope that we know. And we have our y-intercept. And we have another line, L2, that again, that M2 is our slope that we're familiar with. And this B2 is our y-intercept. So suppose we have like these two basic like lines. And this is essentially our slope intercept form. So if we consider, let's say, a point xy on L1, then it has this equation L1, which we just seen. So it determines all those points on that specific line. So we could write a little note. So a point, let's say xy, is of this form of y equals m1 x plus b1. And then let's say we have another point. So another point. Let's say xy is so this is on basically L1. Another point is on L2, and it's of this form. So we could draw like a little sketch to make sure we understand. It doesn't have to have like these axes. So suppose this is our L1. And we have L2. And this point here, this is our x. So this would be, so we would find our x if we have like 2 points that are not parallel. We can find this x. And then we could also find the corresponding y. That's all it's saying. So if the lines intersect at some point, that's if they intersect, like this picture here. If they do, then they have some point xy that satisfies both equations. So if they satisfy both equations, we have y equals m1 times x plus b1 and y equals m2 times x plus b2. We can solve essentially this for x. So we solve this for x. So how do we do that? Well, we equate y equals y, and we solve. So I'll write it over here. So we have m1 times x plus b1 equals m2 times x plus b2, because that's what we're solving for. Back here, we have like this line, and the y's will equal each other. Now, what do? We can subtract negative b1 from both sides. and we isolate that X. Kind of like what we previously have been learning. So it has a theme here. Then we can, of course, move over the M2X to the other side. So it's the same as subtracting M2X. We can factor out the X or distribute it out. And then we can divide both sides by M1 minus M2. This and this cancel, and we get X is equal to B2 minus B1 divided by M2 minus M1 M1 minus B2. Okay, perfect. Which is this right here. So we can solve for X. And this essentially, what is it? So this is the X coordinate of a point, just the point X, of the intersection for those lines, L1 and L2. Now, what can't we do here? Pardon? Those are our y-intercepts right here. The B's were our y-intercepts for our lines. So we can't, so what happens when M1 equals M2? Right, yeah. So then we're dividing by 0 and we got a problem, right? So this expression is meaningful when basically the slopes don't equal each other. M1 does minus M2 does not equal 0. So then we can, if the slopes are different, then they have distinct slopes. And I can talk a bit more about this in the seminars. Please remind me. But like they basically have different slopes. So if they have different slopes, you can find that intercept point. So what happens when M1 equals M2? You can make a little note here. So if M1 does equal M2, then B2 minus B1 divided by M1 minus M2 is not meaningful. It does actually have a meaning. So I can say what the meaning is in the seminar. Because it would need us to divide, by 0, which we don't like dividing. So if M1 does equal M2, then essentially, so if the slopes are equal, then the lines L1 and L2 don't have a point of intersection. So exactly, that's my next, perfect. So this is exactly, so L1 and L2 are parallel lines. So you would notice that essentially M1 would equal M2. You notice the slopes equal each other. And this just basically means, again, that the lines have like these equal slopes. Equal slope. So they're parallel lines. So then the picture would look like something like this, like suppose the slopes go like this. So they don't cross, they don't intersect. So what would that mean? They wouldn't really have a solution then, right? In that case, because there's no intersection. You can't find an X. So in this case, there's no solution. Because they don't cross. So perpendicular lines. So two non-vertical lines are called perpendicular. So we could draw like a little picture. So that's kind of at like 90-degree angles essentially. If and only if, so that means sometimes short form IFF for if and only if, the product of their slopes is equal to -1. So basically, in other words, two lines are perpendicular if, well, it just basically means that they meet at a 90-degree angle. Okay, so we could consider in the next slide two red lines, and they are perpendicular so that they meet at this 90-degree angle. In the next slide, they're going to be called Q, P, and PT. Let's see them. So we have QP and PT, and we see that they meet at like this 90-degree angle here. The angle is 90 because like you could say, okay, this is, and then you could draw another horizontal line to S. And from S to T, let's call that C, and from S to Q, call that B. And then P to S, call that A. And you see that this angle will be 90, and we can say this is 90 minus theta, and this is our theta, our angle. Now, this here would also be 90. And here would be 90. So we can find that this angle here, this is going to be 90 minus theta, and this is going to be theta. We can do a triangle has like 180 degrees, subtract this 90, this angle, and you get that angle. Okay, so we're going to use like this argument of similar triangles. So essentially, if we remember what similar triangles means, so two triangles are similar. Essentially means that their angles are the same. but their side lengths can be different. So we're going to use this idea of ratios to better understand the perpendicular lines. So we have like this red line from P to Q, remember, and another red line from P to T. They're perpendicular, but we're going to try to understand why their slopes are, when you combine them, are equal to -1. So we sort of have like this triangle, this first triangle. Sorry. And this first triangle is Q, let's say QSP, doesn't really matter the order here. And we have this lower triangle down here, which is, let's say PST. So we have two triangles. And remember, this is 90. This is 90. Okay. So let me write in a different color. So in this triangle QSP, the length of the side, let me write this down first, opposite to the angle 90 minus theta is B. We can see 90 minus theta, this is our length here, B. They're opposite. Okay, so the length, and then we can continue this idea, the length of the side opposite to this angle is A. Theta is A. Because see, we have theta and an opposite to it is A. We can actually, I'll just erase this and color code it. So this is our first QSP. Okay. So then their ratio, let's say, of 90 degrees minus theta over theta is equal to B over A. That's the ratio. Okay. Let's go back to blue. So in the blue triangle, or PST, the length of the opposite side or of the angle, let's say 90 degrees minus theta is the length. Here, it's going to be A because it's opposite. Length. And then you see and then the opposite to like this angle, theta, is C. So like their ratio is going to be, well, it's A divided by C. So I can write a little statement here. So we see that 90 minus theta over theta is equal to, the first one is equal to B over A. But 90 minus theta divided by theta, that's also equal to A over C. So this implies B over A equals A over C. So we have B over A equals A over C. So we can multiply like both sides by negative C over A. The left and the right side. Okay, something happens here. Ooh, what happens? The A's cancel. And the C's cancel. And you're left with -1. So B over A, but what is this B over A? So let's go back. Let's go back to the picture and figure out what B over A is. So B over A, let's write it here. It's basically the slope, oh, wrong color. Let's color code it. So the slope is actually equal to B over A. Let's see why. Because it's basically rise over run. You see the change in Y is here. So this is the change in Y. We can use this triangle to denote this change in Y. So that's your rise. And this is your change in X is equal to A. So but this is equal to B. So it's B over A is the slope of the first triangle. So let's write that. So this is equal, this is the slope of the line. QP. And the other one, what color was it? I think it was in blue. You can see this is going to be, in a sense, your rise over your run, but you're going downwards, obviously. So this is sort of like negative the rise because you're going down instead of up. And the run is still A. So the slope here is going to be -C over A. Just because the sheer fact you're going down instead of up. this negative c over a is essentially the slope of the line PT. So if you have two lines and they're perpendicular, and you know the slope of one line and you know the slope of the other line, you multiply those slopes and it's equal to -1. So essentially, we showed that the product of the slopes of perpendicular lines is equal to -1. Good. We did like a little proof here. Yes?
So you just change the name of BA to AC so they're the same thing, and that way you cancel them out.
BA over BC?
Sorry,
Uh,
you change BA to AC because they're the same thing, right? Because I was confused when all of a sudden B was removed for the calculation part.
Here or where?
Yeah, when B times negative BA over AC, they're the same thing, right?
Yeah, A's and A's, they cancel.
Yeah.
And then negative C and the C, they
You change
cancel.
BA to AC because BA equals A over C.
Well, we have like this equation here up here. You multiply both sides by negative C over A. So then you get this. So there's no changing.
I just need B over A, it's A over C, so you can cancel out because they're the same thing. You switch their B over A, A over C.
Here I canceled the A and the A down there and the C and the C here. I got -1. I'm not sure I understand 100%. Sorry. I'm not following. Like,
Yeah.
you can ask me like after class, just
Yeah.
stay around, then maybe. But there's no cancel, there's no switching, so that's.
I just meant that you just change the name from B over A to A over C, so you can do the cancellation.
Oh,
Yeah,
this part I derived. I didn't change it. We derived it here by ratios.
Okay.
So that's the actually tricky part. So we didn't just say it. This is all this part. That's how I got that part. It's and ratios is like an important kind of topic, like even another area. I can go into it, but I won't digress. Let's move on. Okay. So let's look at an example. So we have like these two lines. Are they perpendicular? So you can do this along with me. So if L1 and L2 are perpendicular lines, then what did we just learn? Then the product of their slopes must be equal to -1, right? Okay. So we can find the slopes. We see here, this one is 3, and here the slope is -1 over 3. So since the lines are given, and they're given in this slope intercept form, that's the title, kind of intuitive. We see that, of course, the slope of L1 is going to be equal, I shouldn't write it. The slope of L1 is 3, and the slope of L2 is -1/3. So then 3 times -1/3, what's that equal to? Well, obviously the 3's will cancel out. And we get -1. So therefore, L1 and L2 are perpendicular lines. Which just means that they're at right angles. That's it for that question. You're okay? Wrote it down? Yes?
Is it not 3 minus -1/3?
3
So the rule is M1 minus.
minus? What do you mean?
Like I thought the rule was x equals V2 over V1, or V2 minus V1 over M1 minus M2, right?
We're just talking the intercept line. We're not finding the point where they're,
Oh,
you're thinking of the other formula. This is just essentially the intercept formula. So it's M1 times M2 equals -1 is what we're checking.
oh.
So a line contains like these points. Determine if they're perpendicular points. So find if they're perpendicular. So how do we do this? This is a good quiz type question, or that could be coming up. We find the slopes. So how to find the slopes? Yes. So M1, so the slope of L1, I recommend you know this. So you pick the first one, you have 2 points, you could draw them. This is L1, you have 0.1, you have 0.2 on L1. You could, it's Y2 minus Y1 divided by X2 divided by X2 subtract X1. So let's write that down. So we could take 9. So we could write it X1, Y1, X2, Y2. So 9 subtract 5 divided by 4 subtract 2. So this would be 4 divided by 2 equals 2. So that's the first one. The second one, let's change the color. We have another line, L2. We have 2 points. Let's call them 0.3 and 0.4. And we have X, let's call them X1 and X2 just because, or Y1 and Y2. I know they're different, they're color coded. Just remember X2, Y2. They're different because they're colors. So the slope of the second line here you take 3, subtract 2, divided by 4, subtract 1. So this will be 1 divided by 3. So are they perpendicular? Well, if you multiply M1 with M2, what happens? M1 times M2 is equal to, of course, 2 times 1/3, which is equal to 2/3. And this is not equal to -1. So, I'll write here. So L1 and L2, they're not perpendicular. Not perpendicular. Okay. Yes?
I'm just curious for the last one where we said that if the slopes are the same, they can't be together, they can't intersect because they're perpendicular. Is there ever going to be a case where they're the same line?
Yeah, except for that case, right?
Yeah.
Like if they're different, like if the B's are different, if they're exactly the same,
Yeah. but they're-
right, then they will be on the same line.
Yeah.
So there is that
There's a
case.
where it's accepted and they intersect every line.
Yeah, there are 3 cases. So there's this case where they intersect. There's this case where they're parallel. There's this case where they're on the same line. This one would have one solution. This has no solution. This has infinitely many solutions.
Yeah.
So, I don't want to measure that more in the seminar, not to confuse or give you too much and you get lost. Yes? Of which? Oh, which ones? Of these? It would just be, let me write. So it's just the equation of the line is just y equals mx plus b, right? We have our m that we calculated. So we can write y minus a point, like let's say y1, is equal to m times x minus another x1 point. And then we calculate that and get that equation of the line. So it's a bit more steps here. But if you want, you can ask me in the seminar. I'll see you again. So find the number t such that the line containing the point, like these points, is perpendicular to this line containing these other 2 points, but there's a t here. Okay, so it's a little bit more dicey. So M1 is equal to the slope of L1. Now we know how to do it slowly. So I'm going to speed up here. And you should know how to find the slope automatically if given 2 points. M2 is equal to the slope of L2, which is going to be 1 minus 8. Wait, or no, 1 minus -1, which is, and then the denominator is t minus 8. So this is going to be 2 divided by t minus 8. Okay, and they're perpendicular. So we know some information. So we want L1 to be perpendicular to L2. So therefore, we know M1 times M2 is equal to -1 by definition. So what does this imply? This implies 2 times 2 over t minus 8 is equal to -1. Okay, so now we have to solve this So what do? We multiply both sides by t minus 8. And we got 4 on this side. Sorry. And just multiplying it in. So we got 4 equals -1 times t minus 8. And then we have 4 is equal, distribute this in, -t plus 8, subtract 8 from both sides. And we got essentially 4 minus 8 is equal to -t. This is equal, therefore, to -4 equals -t. So therefore, t equals 4. That would be your other point. So quadratic functions and conics. So now we're moving on a little bit. Remember what a linear function is. So we were just talking about linear functions. So which is of this form, f of x equals mx plus b, which is equal to mx1 plus b. And basically, what did we know? Their graph is a straight line. Let's just say line. So, and we know this. So we're going to start talking about quadratics here. And you've probably hopefully seen this before. So an equation f is said to be quadratic if it is of this particular form, ax squared plus bx plus c, where the first term, this coefficient a cannot be equal to 0. B could be equal to 0, C could be equal to 0, but A cannot be equal to 0. If A were equal to 0, then it becomes a linear function. We want to talk about quadratic equations and quadratic functions. Okay. So we can't use, and just interesting, the German word for quadratic means squared. So this is squared, so you can kind of, or you're learning German in math class. Okay. So how to solve this x squared plus 6x plus 9 equals 5? Well, here, what do we see? We see a equals 1, b equals 6, and c equals 9. So we have an idea. We can rearrange it, sort of. So we could say, and we remember this from previously, a plus b squared equals a squared plus 2ab plus b squared. We remember this, right? So we could use this to kind of solve this equation. So we can rewrite it as x plus 3 squared equals 5. Because it has of this form, because of the 9 here. Because 3 squared equals 9. 3 times x is 3x, plus 3x is 6x. So you could check that this is correct from, and hopefully you know how to do this. You could take this from high school. So take the square root. Both sides. So x plus 3 is going to be equal to plus or minus square root of 5. And then you bring it over to the other side. You have x is equal to plus or minus square root of 5, subtract 3. So we're just subtracting 3. So this has actually two solutions, as you see. The solutions are square root of 5 minus 3 and negative square root of 5 minus 3. So those are the two solutions. So that's okay, it's friendly, that one. That quadratic seems okay, right? As long as you can rewrite it in this way. What about this one? This is a little bit more difficult. So what do we do? Because we have a 10, not a 9 here. So we're essentially going to do this thing called completing the square. So it's a little bit more challenging. So again, we're going to use this idea of x plus y squared is equal to x squared plus 2xy plus y squared. Okay, so we have this. So we have x squared plus 6x. Well, so we could move the 10 over. So that would be negative 5. I won't draw every step. So now what do we do? Well, if it's not in the form we want, we can take initiative essentially and make it into the form that we want, like of this x plus y squared. And then this is called completing the square. So what number do we want there though? So we want x squared plus 6x plus a number. And we want to add it to both sides. So you can see here that we have like a 6x. So our 6x is kind of equal to our 2xy in this format. So this implies, if you do the math here, that essentially y would be equal to 3. And then if you go back here into this equation, y squared is 9. So we would add 9 to this side and add 9 to this side. And then we continue doing the math. And now we can, of course, put it in this form of x plus 3 squared is equal to 4. We can take the square root of both sides. Then we have x plus 3 is equal to plus or minus 2. Subtract 3 from both sides. Sorry. And you get essentially x is equal to 2 minus 3, negative 1. And the other one is, and the other x is going to be negative 2 subtract 3, which is negative 5. So those are the solutions. Now, it's a good idea to, so I'm kind of like happy now, but it's always good to check. So check by plugging these solutions back into the original equation. So you can check your answer. Does the left-hand side equal the right-hand side? Oh, okay. And there is a quick summary here. You can read that. for yourselves. So it just is about completing the square, which is what we just did. Okay.